Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel in this online math classes. Now we are learning the chapter on the binomial theorem, and in our today's session we will be learning how to find the values of the variables given the binomial expansion in its condensed form and in its expanded form. Is it sounding a bit confusing? Okay, let's start with our today's session and everything will be clear to you. So the first question says, given that 1 plus 2 over 3x whole raised to the power of n times 3 plus nx whole raised to the power of 2. So this is one binomial expansion and this is another binomial expansion, and these two are getting multiplied together. So therefore I have said the binomial expansions are given in condensed form and the right hand side is the expanded form. And we can expand this one separately and we can expand this one separately, and the terms, the expanded terms will get multiplied together and the like terms will get added to give us this final expanded expression. Okay, and in case you are not quite familiar with this type of binomial expansions or expressions where two binomial expansions are getting multiplied together, I would definitely be asking you to watch my previous videos. You will find everything given in detail. Okay. So now let us proceed with our today's session. So they are asking us to get the value of n. Therefore, let's start with our answer. So, since this is the first binomial expansion, let me take up this one first. So, I write 1 plus 2 over 3 times x whole raised to the power of n. And in the expanded form, I am seeing there is the constant term and there is a term containing x. And in these two binomial expansions, I am seeing there is no term which is having x in the denominator. Okay. So how can we get a constant term? Had there been x in the denominator and x in the numerator, they could have cancelled each other to give us a constant term. But since we do not have any x in the denominator anywhere in these two binomial expansions, therefore, the constant term can be obtained only by when we multiply two constant terms from these two binomial expansions. Okay. And of course, we see the constant term from this. This is the first term. The first term of this expansion will be in C0. And in C0 is equal to 1. 1 raised to the power of n minus 0, that is n, and 2 over 3 times x raised to the power of 0. So this is equal to 1. In C0 equal to 1, 1 raised to the power of n is equal to 1, 2 over 3 times x raised to the power of 0 is equal to 1. So this is the first term of this expansion. So this is a constant term. This, when gets multiplied with another constant term, will be giving us the value of 9. And what will be this constant term? Let me just write it over here. 3 plus, because I'll be writing some more terms from this binomial expansion, so I don't want to write this just beneath that one. So I'm writing the expansion. This is to the power of 2, there will be only 3 terms. So it will be 3 square, which is 9, plus 2 times 3 times nx is 6nx, plus n square x square. These will be the three terms. Because it is having a power of 2, it is very easy to expand. And we see that when 1 gets multiplied with 9, we get this term 9. So this does not help us to get the value of n. Therefore, the only term that is remaining is 84x, that is the coefficient of x. So how can we have a term containing x? Okay, let us see what is the second term of this expansion. Okay, this is the first term. What is the second term? Second term will be NC1 times 1 raised to the power of n minus 1 times 2 over 3 times x raised to the power of 1. And NC1 is equal to n. 1 raised to anything is 1 and 2 over 3 x. So this is equal to 2 over 3 nx. This is the second term. Since this is containing this x, with what should it get multiplied to give the term with x? Obviously, it cannot get multiplied with a term which contains x or some powers of x. Only if this term gets multiplied with a constant term, will the product term contain only x? Clear? Therefore, 2 over 3 nx should get multiplied with this constant term of this expansion, that is 9, to give the product term containing x. Okay? And how can we get 2x to a term containing x? Is there any other way of getting a term containing x? Of course, there is a second way. We are seeing that 6nx, we are having this term containing x to the power of 1 from this binomial expansion, 6nx. And if this gets multiplied with a constant term, even then the product term will be having a factor of x to the power of 1. So this 6nx can get multiplied with this one. Okay? That is how I had shown you when you have two binomial expansions getting multiplied. It is very essential, if you are not being able to follow this session clearly, then it is absolutely essential for you to go through that video first of all. I'll be giving you the link to that video in the description area. So please watch that video first and then come to the sessions, and you'll be seeing that everything becomes so clear. Okay. So we have seen 1 times 9 is giving us the constant term, the first term 9, and coming to the second term 84x, this can be obtained when 6nx gets multiplied with 1 and when 2 over 3 nx gets multiplied with 9. These are the only two ways of coming to a term containing x. Because if I move on to the third term of this expansion, I don't want to write the third term because I won't be needing it. It will be containing the power of x. It will be actually containing x squared. That is, the power of x will be equal to 2. And since there is no term containing x in the denominator, I cannot reduce the power of x from 2 to 1 anyhow. That is why I am not taking this also. This term is not contributing because it is having a power of x as 2. So I cannot take any other term from this expansion. I do not know what is the value of n. But whatever may be the value of n, there should be a first term. N is not equal to 1. N is not equal to 0. So there will be n is at least equal to 2. So we can have this first term NC0 and NC1. Okay? Because if n is equal to, we can have n equal to 1, doesn't matter. But definitely n is not equal to 0. Okay? If n is equal to 1, then it will be simple 1 plus 2 over 3x. And in that case, 2 over 3x will get multiplied with 9 to give us 2 over 3x times 9 will be 6x. But we do not know the value of n. N can be equal to 1, may be equal to 1. Let us try to find the value of x. Not x, but n. Okay. So we write the two terms, the two ways of getting to a term containing x, that is 6nx times 1 plus 2 over 3 nx times 9. And this should be equal to 84x. And we can safely divide the entire equation by x so that we can get rid of x or we can eliminate x. And we are having the equation as 6n plus, these two will get cancelled and it becomes 6n again. 6n plus 6n is equal to 84, or 12n is equal to 84, or n is equal to 84 over 12, which is equal to 7. So n is equal to 7. This is the answer. This is the value of n. Okay. So now we are done with the first question. Let us move on to the next question. If 1 plus kx raised to the power of n is equal to 1 minus 4x, again this is in the condensed form and this is in the expanded form. So 1 minus 4x plus 15 over 2 times x squared minus the plus and the minus signs are alternating. N belongs to the set of positive integers. Find the values of k and n. So let's start with our answer. This time we are having two variables. We have to find the values of two variables. Fine, no problem. We start with the expansion and we are seeing that x is in the second term, so the powers of x will just go on increasing, and in the right hand side expression also the powers of x are increasing. For the first term it is x to the power of 0, second term x to the power of 1, third term x to the power of 2 and so on. Okay. So we can, and of course what will be the first term of this expansion? It is NC0, 1 raised to the power of n minus 0, that is n, and kx raised to the power of 0. So this is equal to 1, which we are seeing. So this is the first term. This does not help us in any way. Let us move on to the second term. Equal to NC1, 1 raised to the power of n minus 1, and kx raised to the power of 1, equal to NC1 is n, and 1 raised to any power is 1, and this is kx. So this is nkx. This is our second term. Okay. And we are seeing this is having a power of x as 1 and this is having a power of x as 1. So we can equate these two. So we have this expression, or sorry, it is an equation. Nkx is equal to negative 4x. So we can cancel these two x and we get in k equal to -4 as our first equation. Okay. Coming to the second, we have done the second term, so it is the third term. In C2 times 1 raised to the power of n minus 2 times kx raised to the power of 2. And what is in C2? It is n factorial over 2 factorial times n minus 2 factorial. And 1 raised to the power of n minus 2 can be ignored, and this is k square x square. Okay. And this is equal to this term, 15 over 2 x square. And we can divide the entire equation by x square so that these two will be getting cancelled. And we can multiply the entire equation by 2 because 2 factorial is 2. So if we multiply the entire equation by 2, these two will get cancelled. Clear? Now, coming to the simplification of this factorials, it is n times n minus 1 times n minus 2 factorial over n minus 2 factorial k square is equal to 15. Okay, and these two will be getting cancelled. Let me come to this part. Okay, so, and I can expand this. This is n square, n times n is n square times k square, that is n square k square, and n times -1 is negative n times k square. So it is negative n k square is equal to 15. Okay. And n square k square can be thought of as, let me write over here, n square k square is equal to nk whole square. This is not having much space, so n square k square can be thought of as n times k whole square. And what is n times k? N times k is equal to -4. Okay, so it is -4 whole square, and this can be written as nk times k is equal to 15, and -4 whole square is equal to 16. So it is 16 minus of -4 times k is equal to 15. Okay. So this is 16 plus 4k is equal to 15, or 4k is equal to -1, giving us the k value as -1 over 4. So this is one of the values that we were asked to get. K is equal to -1 over 4. This is just, okay, this is, let me make this an ellipse instead of a rectangle, because I have made a rectangle around k equal to -1 over 4. So this one is an ellipse. And now what is remaining? Value of n. And nk is equal to -4 from this equation 1. So nk is equal to -4. In place of k, I write -1 over 4 is equal to -4. And these two negative signs can get cancelled, and This gives us the n value as 16. Okay. So we have found the values of both the variables. N is equal to 16 and k is equal to -1/4. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.